With our cryptocurrency fully implemented, let's spin up a couple instances of the application and explore the project with all of its features. To begin, let's go to the command line and run one instance of the app with npm run dev. And now on a second tab, we'll start up a second instance with the usual adjusted environment variables. So first we have a change HTTP port. We'll make it 3002. Likewise, our changed peer-to-peer port will be 5002. It has one peer, which is the WebSocket address of the first instance, so ws://localhost port 5001. And then we'll run npm run dev, and then these two instances should be connected to each other as sockets. All right, now that these instances are connected, let's open up Postman and start conducting some transactions between these two instances. First up, let's send some currency from our first instance to the second one, but to do so, we'll need the address of our second instance, which we can get by hitting localhost port 3002/public-key. As we do so, the response we get is the long public key, so let's copy that long address. And now in the second tab, we can make a post request hitting the transact endpoint of our first instance to send currency to that address of our second instance. So let's make a post request and then hit localhost port 3001/transact. We'll go to the body tab and select raw application JSON. Then we have our JSON and we need to specify the recipient of the transaction. So go ahead and paste in the big address that you copied from the first tab within a pair of double quotes. Then we have the amount to send from this first instance, which will be 50. All right, let's go ahead and make a couple of these transactions. And as we do so, the transaction output object that we have is that we have 400 left over for the first instance, and then we're sending two output objects to the second instance by its address of 50. Excellent. All right, now a couple of transactions have occurred, so let's make sure those transactions exist as well within the transaction endpoint or transactions endpoint of each instance. And indeed, the transaction pool has the transactions within the first instance. Let's check the second one as well under port 3002. And great, we get the same object. Cool, the transactions are present. Now let's actually mine those transactions using any one of the instances, but how about the first one by hitting localhost port 3001/mine transactions. And as we do so, it generates a blockchain as a response for us, whose second object is this big transaction list, but it contains that transactions object we generated from before, and also the reward transaction for the original miner, which was this localhost port 3001, which did the act of mining and received that reward. Great. So depending on how many times you conducted the transaction with the original instance, the wallet should have a decreased amount of currency. So for example, if you created the transaction twice, it should end up with around 400 currency, but then added 50 currency for the reward if you also mined with that original instance. So a way we can check that balance is by conducting another post request for a transaction. So let's click the send amount. And then if we look at the input amount generated now from the first instance, well, now it's 450, just as we expected. Perfect. The balance of the wallet appears just as we wanted, with the subtracted amount from all of its previous transactions and the added amount from its reward. Overall, we now have a pretty powerful blockchain and cryptocurrency on our hands. That completes the project for now. But there are more than a few additions we can make to this blockchain and cryptocurrency to make it even more secure and powerful. But this is more than comprehensive enough to get a good understanding of how these concepts all tie in together. Congrats on building this blockchain project. I hope you enjoyed it, and let's move on.